Hello, and this is, despite other slides to the contrary, the myth of the genius programmer. And before we get started...
Should do some introductions?
Should do some introductions. Your mic, can't hear your mic again.
Can't hear my mic at all.
Right.
Oh, let's fix that.
You need to. Okay.
Hey, so let's do some introductions. Who are we?
My name is Brian Fitzpatrick. I usually go by Fitz.
My name is Ben Collins-Sussman. I usually go by Ben Collins-Sussman.
And we're basically a couple of longtime version control geeks. We worked on Subversion years ago.
And we have a lot of experience in the open source world, so we tend to speak about things that are related to open source, but not necessarily related to open source. That's just our...
Right, we started at Google. We worked on code.google.com. We still work on Google Code, actually.
Mm-hmm. Absolutely. And if you're interested in the project hosting service, which is what my team works on, we're doing a talk tomorrow about our Mercurial implementation on top of Google infrastructure, which is a new feature on Google Code. So come see that.
So, but enough about us. Who are you? So we have a couple questions for you so we can get an idea about the audience. Survey. So how many people in this room write code entirely by themselves only? Never with other people?
Or how many people like writing code by themselves, though?
Right. Yeah, that's okay.
Fun. Yeah, all right, that's great.
So how many people work in teams? Okay, that's good. Everybody's awake. How many people in this room do code reviews as part of your development process?
Wow.
That's that good or bad?
I'm impressed. That's great.
All right, one last question. Who is afraid of looking stupid in front of other people? All right, we're in the right place. Excellent.
So before we go on, we should let you know these are very opinionated talks that Fitz and I give every year. They're really based on our own subjective experience, and that's fine. You know, if we say things that upset you or anger you, we've done our job.
Right.
And we encourage you, if you don't like it, you can...
Yeah, if you have different opinions, please get your own talk at your own conference. So, before we go, though, we're going to have you do a little more work. You're going to have to read a few slides and check out some of our quotes here, what we've got. So,
what is this talk about?
We're not going to read them to you, so this is the first one. All right. The second one. Okay, and now for a really good one.
Okay, so what do these all have in common? Can you guys have any ideas here? All right, it's a rhetorical question. But, right, so what's going on here? There's a lot of insecurity going on, right? And this is a common feeling that we all have. So we're going to go off of this. I mean, we were actually getting these responses last year at I.O. People were coming up to me and saying these sorts of things. So it's got us thinking about, well, what's going on with psychology here? What's going on in people's heads? Why do they want to hide their code so much? What's really at the bottom of this? Which is how we came up with this talk, and where we get this idea of the myth of the genius programmer. Well, let's do one more quote.
Okay.
Interesting.
So this is rooted out of a general desire to not look stupid. It's sort of everybody I think wants to look like a smart developer. I know I certainly do to some extent, but there's a lot of different reasons behind why people do this. And we're going to start with something a little almost seemingly unrelated. But why do people buy products endorsed by celebrities? Okay, Michelle Obama wore this dress to the inauguration. Okay, boom, suddenly it's sold out. All right.
Or Michael Jordan wears Nike shoes, right? Everyone wants to buy Nikes because they love Jordan or basketball or something. What's really going on there? Like, do you actually believe that if you buy Air Jordans, you're going to be as good as Michael Jordan?
Yes.
No, but no. There's something going on, right? There's some nugget of human psychology going on here where it's in our instinct to find celebrities, find people to idolize, and want to be like those people, and we sort of latch on to whatever simple behaviors or materialistic pieces that remind us of this celebrity or this behavior.
And that's true in the world of programming as well. I mean, we have our heroes. We have Linus Torvalds. To some extent, Bill Gates even. Guido here at Google, he wrote Python himself, right? Not quite true,
Did Linus write Linux all by himself?
Right. We have, Kernighan and Pike and Kernighan and Ritchie. I mean, these guys don't always deserve all the credit. They certainly deserve some of the credit. They're the leaders, right? Or they sort of started something. But they're mythologized. So the personas that they become are bigger than life to some extent. And to some extent, rooted in a little nugget of truth or fact, and a whole lot of myth.
So that's why we have this myth. When we say the myth of the genius program, we're talking about the myth of, hey, here's a genius, and genius goes off in a cave and writes this brilliant thing, and then reveals it to the world, and oh my gosh, this person's famous forever, right? Reality is that's not really how it works at all. In fact, geniuses, they are so incredibly rare that, I mean, it's kind of a meaningless term, right? I mean, those folks, that myth just isn't true.
So the ultimate geek fantasy is to go off into your cave and work and type and code and then shock the world with your brilliant new invention. It's a desire to be seen as a genius by your peers.
But there's a flip side to that too, right? It's not just about I want to be a genius and shock the world. It's also I'm insecure. And what I mean by that is, I also don't want people to see my mistakes. All right, maybe I won't be a genius, maybe I won't shock the world with my brilliance, but at least I don't want them to see my trail of failures and mistakes, and I'm going to cover my tracks, right?
But people want to be seen as being clever, right? And so the result
clever people don't make mistakes.
Right, exactly. So the result is people wind up working in a cave. The classic example of this is how long will you drive around before asking for directions? Okay? How long are you going to be completely lost before asking for directions? Well, you're not going to say, "Oh, I'm lost. I'm immediately going to ask for directions."
Well, it's hard to admit that you've made a mistake sometimes, especially publicly, right? So that's why we show these quotes in the beginning with people saying, "Well, can you erase my history? Can you hide my project until it's perfect?" Right? I mean, it's more of this. I don't want to show everybody what I'm doing till I think it's perfect.
Right. So you may be thinking, "Well, big deal.
Why do we care?
Why is this a problem? Why should I care about this?" The primary reason is it inhibits progress, and not just personal progress, but project progress. Okay, it's sort of the many eyes make all bugs shallow quote. But if everyone's off working in a cave and just occasionally throwing code out to the project, code quality remains low, and your bus factor remains low. How many people here have ever heard of the bus factor?
We talk about it every year.
Okay. Weren't you here last year? No. Okay. Bus factor is the number of people on your software project that have to get hit by a bus that are going to leave you in a world of hell. Okay? All right? So if there's only one person that knows that really obscure file system code and they get hit by a bus, whether that bus comes in the form of an actual bus, or they get married, or they have a kid, or they change jobs, right? Or they move away, or they get bored.
It happens all the time.
It happens all the time.
So this is one of the things we talk about all the time in teams, whether it's a team at your work or a team on an open source, is to not get so territorial that you have low bus factor on different components, right? It's a common thing, right? You can't touch that code. It belongs to Joe. Well, wait a second. What happens if Joe's gone, right? Now you're in trouble. So one of the things you should be watching out for is, you should have as many people touching and getting familiar with as many parts of the code as possible. You want that redundancy on your team. But if you're off working in a cave and you're hiding your tracks, well, no one knows what you're doing. No one knows.
You could be working on the wrong thing entirely, actually, if you're off doing some really big feature, a big piece of code.
Well, here's a nice analogy that we like to talk about, which is, think about the way you interact with your compiler, right? You have a really tight feedback loop, right? You write a function, you compile it, you make sure it at least compiles, right? Maybe you write a unit test if you're doing great, right? But nobody sits down and writes, thousands and thousands of lines of code and then runs their compiler for the first time. It just doesn't happen.
Not
right?
Anymore. Maybe 50 years ago, right? Yeah.
Right. Not in the mainframe days, maybe. But so, it's the same way. If you're working on programming in any way, you should not be doing it all in a cave and then sort of waiting to spring it and see what happens. You want other people seeing what you're doing as soon as it makes sense, right? And we'll talk about what that is.
Right, but in addition, if you're off in the cave, you don't learn as quickly. It's harder for you to improve your skills, right? There's a balance between spinning your wheels and being lost and asking the person next to you every question that comes into your head, right? But this problem isn't unique to computer science. It pervades all sciences, math, anthropology, especially when you get into hard research. You see this sort of thing.
Well, I think if any folks are in the academic world, when computer science is part of this, there's this constant tension, probably caused by the publish-or-perish philosophy, right, where, you're all supposed to be in academia, you're supposed to be sharing knowledge and collaborating and helping each other and cooperatively advancing the state of the art, but everybody has to hold their research to their chest and not show anybody what they're doing until they're published, right? And what happens? Oh, you end up publishing a paper which is redundant with somebody else's paper, right? Or maybe you worked on the wrong thing and didn't realize it because you never told anybody what you were doing. Or maybe if you had collaborated with this other person, you guys could have written a better paper together, right? Same exact tension, just in writing software, right? the sooner you get your idea out and other people looking at it, you can find out, am I working on the right thing? Do I have the right idea? Should I go back to the drawing board?
Right.
Should I be collaborating with this person because they're working on it too? I mean, it's the same issue.
Right. So this is a little bit of more bad news to this for you, okay, is that you're not a one of a kind, right? Okay? If you're 1 in a million, right, that means there's over 1,000 people just like you out there right now, okay?
That's true.
But glad you guys like that, thanks. But even if you're a genius, working well with others may make or break you, okay? Like attracts like. And, we work hard to hire really smart people at Google. And I don't care how smart you are, if you can't sit there and communicate with someone else or work together in a team and achieve consensus, you're not going to be successful on working on a team of people.
This is one of those things that I always try to communicate, especially to students who are just starting out in computer science, that software, even though it's fun to write code alone, late at night in your basement, whatever, actually writing software that's successful it's an inherently collaborative activity. And it actually forces you to deal with people and talk with people. And that's why we encourage people to get involved in open source, because it's sort of like, okay, well, maybe you're still in college, but here's your chance to actually work with people and work on a team and see what it's going to be like. One of the things I always ask people is, can you name a piece of software that's really successful, really widely used by a lot of people, and was written by one person?
And before anybody yells out Metafont, that's not widely used, okay? But anyway, so this is a trap, okay, of this sort of wanting to be a genius. So how do we avoid this, okay? Quite frankly, the first step is to drop the ego, okay? Instead of having a large personal ego, which actually impedes collaborating on a project, have a strong collective ego around your project or the piece of software you're working on. A great example in the open source world is the Apache Software Foundation, okay? Community is the essence of every project in the Apache Software Foundation. That's what's most important to them, more so than code. Companies call Apache up all the time and say, hey, we want to give you guys 1 billion lines of code and blah, blah, blah.
And then walk away.
And then, have a nice day. And they're like, we don't want it. We don't want a pile of code by itself. It's just going to bit rot. We want to build a community around this. And so as a result, people working in the projects tend to be proud of. I mean, I don't know about you guys, but I want to be proud of the stuff that I'm working on.
Absolutely. It's a good way to keep your project healthy, too.
Right. So you don't want to be this guy, basically.
Not in your project. The next thing to think about is how you interact with people. How do you give each other feedback? And it involves, actually being a nice person. I know it's crazy. But it is a learned skill to give constructive criticism, whether it be a code review or just a discussion of design. And to take criticism as well. And if you work in open source, you learn to be pretty thick-skinned so that you can take non-constructive criticism along with the constructive criticism. But it's something that we should all aspire to do, right, is how to do it in a nice way.
Right. And the way to look at it is that your code isn't part of you, right? You want to work for the best piece of software as a whole, not to sort of get your one little clever bit in. Mm-hmm. So here's an anecdote. A friend of mine left Apple a few years ago, went to work at a smaller company that had been around for a while as an engineering manager, and he went in and he saw that they were using version control, and he set up so it would send out code review emails because they weren't sending out code review emails. And he started doing code reviews. And he thought, okay, I'm going to try and get these guys a little more rigorous engineering. We'll have some better practices here. And a week and a half later, the director of engineering calls him in and says, I've been getting a lot of feedback that you're really bringing people down with all this negative criticism of everybody. He's like, what are you talking about? Yeah, these code review things you're doing, it's just people are getting really upset by that. And, how do you respond to that? This is something that is really integral, I think, to writing good software.
That's a cultural problem, too, in some companies, right? Some people really, especially in a lot of corporations, you'll see not only territorial, this is my code, you can't touch it, but also, how dare you tell me what to write or make comments on what I just wrote and mind your own business. I mean, that's right. That is a very common behavior, and it's hard to get companies to break out of that cycle, increase the buzz factor, do code review all the time. At Google, we're not allowed to submit code into our version control system until there's code review. Like it will reject your change until there's proof that some peer has looked at what you've done and given a thumbs up, which is a great thing.
All right, so criticism is actually good. And the next important thing is that you have to learn to sort of embrace failure, okay? Mm-hmm. People, I'm afraid of failing. Certainly, I think most people are, okay? But, the whole NASA failure is not an option thing is a load of crud, right? Failure is an option, except in one case. It's failing on the same thing repeatedly. That's never good because you're not learning, right?
And it's embarrassing.
It's embarrassing, but if you're failing, if you try something and fail, try something different and fail, and you try something different, every time you fail, you learn something. And for many people, that's the best way that they learn how to do things. Some people learn by sitting in a room and hearing two other guys yammer on forever. Some people learn by reading a book. Some people learn by looking at pictures. Some people learn by trying and failing.
Well, this is why it's also important. It's another cultural issue here is when failure does happen, be ready for it. Don't freak out. Document what happened, what did you learn from it, what are you going to do different next time, right? That's why we do postmortems on, when there's something crashes or there's some bad thing happens. We write it up and learn from it.
Right, and it's not, the point is not to assign blame. It's to look at what you did, have everyone else look at what happened so that we don't have to do this again.
I think a big issue also around failure is just natural human fear. I can relate to this personally. I started learning banjo a few years ago, playing in bluegrass jams, and they would occasionally try to call on me to do banjo solos, right? And which is really, really hard to learn, and I just wouldn't do it, or I would, bow out. And someone took me aside and they said, you realize that 50% of learning to solo is just not caring how good you sound and just losing the fear. It was totally true. I was like, all right, these are my friends. If I sound terrible, who cares? And sure enough, he was absolutely right. I just started playing really bad solos, but it got better and better, and I kept learning, and that was a huge step. So, if you can just make that mental shift and say, it's all right, I'm going to fail, and it's not a big deal, no fear, that's fine. You move on, you learn. You've got a better anecdote.
Well, this is a complete anecdote. It's a story about the executive who makes a bad business decision. The company loses $10 million for the company. Next morning, comes into work. His secretary says, the CEO wants to see you in his office. And the guy hangs his head down. He's like, this is it. I'm going to get fired. Walks into the CEO's office, and he's like, so I guess you want my resignation. The CEO looks at him and says, resignation? I just spent $10 million training you. Why would I fire you? But again, I bet you that's a mistake that guy never will make again. I lived in Italy for 3 years, okay? I moved there, and I'd been studying Italian, and I was really proud to use my Italian. I went into a cafe, and I ordered a sandwich, and they gave me this massive sandwich, and I wanted a knife to cut it with. And so I thought I'd be cool and use my Italian, and I promptly asked them for a toothbrush to cut my sandwich. They just looked at me, and I'm like, toothbrush? And he's like, no.
It's true,
but
yeah.
Never made that mistake again.
Speaking languages in a foreign country, it's very intimidating. You're just so scared of looking like a fool, but
right.
You don't learn otherwise. So.
Well, it's the easiest way to learn, I think. That sort of hot white fear you get going up your neck as you ask for something embarrassing.
So failing it's not just about embracing failure, but it's also failing fast, right? What we're talking about, iterating as quickly as we can. This is something we actually talk about a lot at Google is don't just fail quickly and pick up and try something different as fast as you can. And that's why we've got this Google Labs site now, right, where people are experimenting with different projects, and if they fail, that's fine. They'll just put something up or change it the next day and try it again, right? The faster you can fail and the faster you can iterate, the faster you will learn and get better.
And you don't have to hide it if you fail. It's okay. You don't have to hide your tracks. We talk about in the version control world. People use subversion versus mercurial versus Git, et cetera. Git rebase is something that people use often to sort of hide their tracks. There are some legitimate uses, I think, if you want to clean things up a bit. But
or maintain a vendor branch.
Maintain a vendor branch, et cetera. But people are typically looking and say, I was working on all this stuff. I made all these sort of false starts. I don't want anybody else to see, my stupid mistake here where I forgot to check the type of something.
Rewrite my history, so it's perfect.
That's right. Yes, exactly. Just like the history of the world. But what it comes down to is one of the ways of making this problem better is to practice, okay? If you practice, it makes your iteration failure cycle faster, okay? And it basically it's sort of less scary to fail because you'll tend to have smaller failures.
The failures tend to get smaller over time, and the successes tend to get larger, and that's a trend you'll see, especially if you're learning as you fail fast.
Right. And the next thing is sort of to be a small fish, all right? If you are the senior developer on a team or in a company or something, and everyone looks to you and you're sort of the teacher or the king, queen bee, whatever, if you're only working with people junior to you, you are going to learn things from them, but it's going to be harder to improve your skills than it would be if you were working for someone with someone else who is smarter than you, who is a better engineer than you.
It's actually, in my experience, when you're a big fish in a pond, it's very comfortable, but you're not really learning very much, right? You feel safe, but you don't get much better. And when you are a small fish in a huge pond, it's very scary, right? I mean,
sometimes you get eaten, though.
That's what it was like when we started at Google, right? I mean, it's very like, it's just so many people. And but you get better really quickly, right? It's all about the reward of facing that.
It's like the old Emacs joke, it's got a really steep learning curve, but that just means you learn a whole lot in a short period of time, right? But beyond being a small fish, the other thing is to sort of, and this has to do with not only being successful, but also being a leader, which is to be influenced, okay? Because the more that you're open to the influence of other people who might have a really good idea or a novel way of looking at something or accomplishing something, the more actual influence that you bank can have on others, the more likely they are to listen to you.
Respect is a two-way street, right?
Right.
But I would say it's not just about respect being a two-way street. It's about vulnerability, in that if you can show yourself to be open to change and willing to admit mistake. I guess being vulnerable is another form of being influenced, right? It's an extreme case. If you can admit your mistakes in front of your peers and say, I was wrong, I made the wrong choice, I had the wrong opinion. A lot of people are afraid to admit that because they're afraid, in the short term it's going to make them look weak or like they don't know what they're doing. But in fact, if you think about people that you really admire, who you may have worked with, they make themselves vulnerable a lot, and over the long term they get perceived as big figures, big strength figures, right? Wow, that person is so strong that they're not afraid to admit mistakes and failures.
Well, and it's not just about their ideas or their way of doing things. It's a way also to sort of cement people's dedication to what your project is or what you're doing. Because, we like to talk about buses a lot, I guess, but it's the difference between being the person driving a bus and a whole bunch of people as passengers that are following you and taking turns driving the bus, right? If you're working on a project, whether it's an open source project or within a company, where different people take the lead at different times, you're going to attract a different caliber of person or a different type of person who wants to participate and carve out the path as opposed to simply following you.
Absolutely. So let's talk about, we're in a little diversion here and talk about software tools, since that's our background is in software tools. And talk about specifically how they affect your collaboration and your social habits. One of the classic internet sayings, right, is you can't fix social problems with technical solutions, right? And there's all sorts of classic examples of, like, for example, the whole DRM issue, right? If we just keep inventing more and more complicated DRM technology restrictions, that'll fix the problem, except most people will say, well, really, there's some kind of social issue here about what is intellectual property, what is fair use, what is the nature of it.
Isn't that problem solved yet? Nobody downloads music anymore.
But it's clearly, it's
right?
a societal, cultural issue, right? Not something that can just be papered over with ever more complex DRM technologies. Another one I talk about is in version control. I see a lot of administrators will start, especially in open source projects, they'll start trying to do path-based access control and say, this person's allowed to commit to this branch but not this one, and this person can only commit to this file but not this one. They start creating all these complicated rules, and I sort of say, all right, well, what's going on here? Why are you creating all these technological restrictions? Oh, we got to make sure people don't commit to the wrong places. And I'm like, well, if they did, what would happen, right? You would all notice it. You'd roll it back, right? Because it's a version control system. You can undo, right? You'd ask the person what happened. If it was a mistake, they apologize. If it wasn't a mistake, they're in trouble, right? Or you tell them to leave the project or something. So it's sort of like, okay, it's a social problem. You don't need this technological restriction to solve it, right? It's not a good solution.
Well, or the endless spams arm race, right?
Right.
It goes back and forth, right?
The social problem being
more spam comes.
The world is full of jerks.
Right, exactly. Yeah, exactly. That's the thing. The internet. That's what I would say. Is the world is full of jerks, but the internet makes it seem like they all live right next door to you, right?
Especially.
So you can't use technology to solve these sociological problems, right?
Well,
not always. Okay, it's a false truth insofar as there are things you can do to encourage people to quote unquote do the right thing, right? For example, on Google Code, if you want to comment on an issue, on the issue track, if you want to create an issue or something or file a bug, you have to sign in. All right? There's a very simple reason for that. First of all, we want to limit spam a little bit, but more importantly, if someone reports a bug, it's nice to have a way to get back to them. Can't tell you how many times in the past people have reported bugs out there, and they leave no contact information, or they screw up their email address or something like that.
Right, so that's an example of a small technological change having a big social impact.
Right, it doesn't solve the problem.
No, but it definitely changes behavior.
Right.
Another example is on Google Code project hosting, we only allow a small number of licenses, which angers a lot of people, right? They want to come in and use, some open source license that's fairly obscure, and they say, why isn't it on the site? And our answer is, well, because we want to stop the proliferation of open source licenses. We think it's bad for the open source world. And that's fine. Either they'll choose one of the standard licenses or they'll go host their code somewhere else, which is okay. But we've had a definite impact, a social impact, through that small technological choice, right?
Right.
So yeah, sometimes you may not be able to solve gigantic social problems, but you can have, small technological choices can have big social behavioral changes, right?
So defaults are important, okay? I mean, you want to examine how do tools behave out of the box, okay? This doesn't actually fix the core social issue at hand, but it does influence people's behavior quite heavily.
So let's look at how some software tools behave. What's their default behavior, and how does it affect the way you collaborate? One example is how about on your software team, when somebody commits a change, maybe you do code review beforehand, but certainly in the open source world, it's pretty common to do code review after somebody submits a change, right? In a lot of projects, an email will go out with the diffs, and it'll go into all the mailboxes of all the participants. And what's cool about that is that it makes it almost effortless to do code review, right? It's like their changes are being pushed right to your face, and you're reading your email, and you're like, oh, looks like they got a typo there or a bug. Let me reply really quick, right? As opposed to projects that don't do that, there's almost no code review at all, right? Big social change for a small technological
and
trick.
Sort of set the Wayback Machine before the internet was really popular and open source was really huge. How many people here have heard of CVS? The version control system, not the pharmacy. Okay, good.
We actually asked a bunch of students. We gave this talk a few weeks ago to a bunch of students, and we asked how many people heard of CVS, and they all raised their hands.
I was blown away.
And then we were like, well, you're only like 19. And they're like, oh, how many people heard of the version control system? Nobody raised.
No one at all. Which is good, really.
Let's change that slide.
But people talk about open source game day. They talk about Richard Stallman. They talk about Linus Torvalds. But CVS actually played a really important role insofar as there was a feature created in the mid-'90s called anonymous P server. It was anonymous network access, where any random one of these jerks on the internet could download your source code into a CVS working copy, fiddle with it, and then send you in a nice, small, concise patch that could fix a bug, add a new feature, et cetera.
That was a huge social impact,
It had a huge impact insofar as it made it virtually effortless.
Mercurial? Few, okay. Darks?
Bazaar, anyone?
Monotone?
No, I'm just kidding.
Codeville? Okay. Distributed version control is kind of interesting. Like, what are the default behaviors in distributed version control? It's sort of a double-edged sword, right? On the one hand, it's kind of not so great because the default behavior when you start off is to fork, right? You start off grabbing the entire history and crawling into a cave, right? And it's actually a little bit more work if you want to contribute your code back. You have to find someone else to talk to, find a server, do a push, right? I mean, it's actually, there's a little more effort involved. So in one sense, it discourages collaboration. But in another sense, it also encourages collaboration because, it lowers the barrier for everyone to participate, right? Instead of just, the official committers on a project having access to the history, having the ability to do checkpoints of their code, now everybody in the world has the exact same tool set, and everybody can checkpoint their code and do whatever they want, and there's no, being a committer really just becomes a social title, right? It becomes a branding job rather than I have special tools and you don't kind of thing.
And I think this is really great, but I think it does concern us a little bit that, what are people going to do in 4 or 5 years? Is this going to sort of tilt the dial back in the other direction for collaboration?
But like I said, it lowers the barrier for people walking by to participate, right? I mean, in the old days, you had to, check out the code, email a patch, wait for somebody on the list to review your patch. Maybe they liked it, maybe they didn't. You were kind of helpless. So now you don't have to wait for that. So it might be a good thing, too. So.
Right. So there's a moral to this story, right? Which is you need to pay attention to the default behaviors of the tools that you have. And you need to ask yourself, what is the social behavior of this tool that this tool is encouraging for me to use? Mm-hmm. And that can vastly affect the dynamic of your team, basically.
So there's one more thing we want to talk about, which is how to, right, so we're talking about, fine, we want to collaborate. Collaboration is important. Don't be afraid. Pay attention to what your tools are doing. But here's the big question: when is a good time to collaborate, right? Do you do it early on? Do you do it late? So we have done some wonderful research.
Minutes of research.
About the evolution of a project, right? I mean, it starts out as an idea in your head, right? And then after a little while, you make a prototype just to sort of show other people, or maybe just to satisfy yourself that it's going to work. And then you say, hey, come take a look at this. You show one person or a few friends. Oh, sorry. Nice. And then you write a lot of code, and then you dominate the earth and everything is fine. So the real question is, while you're doing this phase, first of all, you don't have to hide, right? I mean, you can do all of these phases in the public eye. It's really a question of at what point do you start advertising yourself, right? Like, even if you're still working on a mock-up, it's not like you need to be in a cave to do that, right? Chances are most people aren't going to know you're working on that mock-up, even if you're doing it on an open source repository, right? They're not going to see you until you start screaming and mailing lists and saying, hey, come look what I'm doing. So.
Right, but the real question here is, where does the third milestone go, right? You don't want to start involving people too early or too late. For good or for bad, people typically involve people too late. It's rarely that someone involves people too early. If you're done, it's too late. Okay, but there's a huge risk of wasting your own time. You might be trying to come up with a project to change the world. It might be doing something open source. You might be just coming up with sort of something in your spare time you want to pitch to your team that you work with at the office, right? But if you go off and you get to make a whole lot of progress without talking to the people, getting some feedback, there's a huge risk of just wasting your own time. You could have really bad design choices that are undoable without starting over. Anyone, those of you guys who do code reviews, if you ever get somebody who gives you a 5,000-line code review, what can you really do with that other than check it for syntax or check it and say, oh, you forgot this is 2 spaces here, it should be 1.
Well, I mean, it's too late to really go back and make significant changes,
right?
I mean,
and you're not going to want to digest all that. To digest what that amount of code would do, you really want to see a design doc or talk to the person about it.
Yep. The other issue is that a lot of people aren't going to be interested in your project because there's no opportunity for them to take stake, right? If your project's 95% finished, why would I want to get involved when it's mostly done, right? There's very little opportunity for me to come in and make a mark and feel like I'm really affecting the direction.
Right.
So you can talk about brain crack.
Brain crack. So anybody here ever watched C.J. Frank on the web? He had this thing called The Show a few years ago, right? He had this one episode where he talked about brain crack. It's these ideas people have. People have ideas all the time. You have an idea and you think, this is a brilliant idea. You sort of nurture it in your head and you think about how wonderful it is and there's angels around it and it's going to be the greatest thing ever. You never act on it because as soon as you try and implement it or act on it, you usually find out that most of them are garbage. Okay, but you keep these ideas to yourself, and they're sort of like, he calls them brain crack, because you just feed on them. So the point is to try to get things out as quickly as possible.
Well, let's look at the opposite scenario, right? What happens if you start getting collaborators working with you too early in the process? And the answer to that, I think, a good example is go look at a huge number of projects on SourceForge or Google Code where there's like one author, and there's nothing up there but like maybe a wiki page that says, dudes, we should write this cool software to take over the world. Let's talk about it, right? And one of two things happens. Either nobody cares and nobody comes and nothing happens, or because there's no prototype, there's nothing to look at, right? Or, even worse, 50 people come or 100 people come and they all want to do different things, and you end up sort of having this endless discussion about what it could be, and you get into sort of this design by committee where nothing happens. right? And the whole thing just kind of stalls.
Well, you run the risk of attracting a lot of people that don't want to do what you want to do. Okay? You want to go there, and somebody shows up and wants to go here, and you didn't really communicate that you wanted to go there in the first place. So they're not wrong. You're just going to waste a lot of time and energy.
Big time. So what you want to do is you want to go for the sweet spot. And what we call the sweet spot is you have a coherent design and a mission statement, right? Clearly written out on your website, goals and non-goals, and what the purpose is, exactly what you're going to do, so people can't show up and completely derail the direction that you've chosen, right?
Right.
And you got to have some amount of running code. Doesn't have to be a lot, just enough to say that you're serious and to get the idea going in other people's heads. Just a proof of concept, right? Or just a mock-up or something, so that it's far enough along that it feels like there's some inertia, right? But not so far enough along that people feel like, oh, I can still get in and get involved and really influence this project, right, and make a mark. There's a lot of work to do still.
Right, but you have to be ready to make revisions, right? You have to be ready for that, for the criticism, and make some changes and discuss and backtrack and
document your failures.
Right, don't hide the history. I mean, that's really it's a really important thing. One thing that we noticed a lot in open source projects is that there's a lot of documentation about what they're going to do and what they'd like to do, and sort of in cases what they've done that's worked for them. But rarely do you find any documentation of stuff that they've tried that they failed at. You know, people give a design doc that didn't work, they just delete it. Like, oh, I want to pretend like that never happened, right?
That whole branch never happened.
Right, exactly. But in a lot of cases, this can be a huge time saver, because let's say that you're having a huge discussion about something, and you go off and you try it and it doesn't work, so you delete the code and whatnot. A year later, someone comes up and has this huge discussion. They want to try this great idea that you did last year and failed. Okay, now it's easy enough if you can point them to the change list where it happened and the mailing list.
Right? What if you're gone? What if you've left the project, or the person who tried the experiment is gone and they're not there to remember?
Right.
Or even point you to the deleted branch or the deleted docs.
Right.
I mean,
it's good to have that mailing list, that thread there that happened. And it's not bad. It's okay. The world is full of false starts that eventually rot away. But we have a couple of case studies here to talk about. First of all is subversion, which is was our project many years ago. And you go ahead and tell
Well,
them.
I mean, I don't know if this is the model, but we think we did a pretty good job with starting this project. I mean, it started out with 3 guys in an office writing a design doc together, just the 3 of them. It took us maybe 2 weeks, 3 weeks to actually get it right. And I think 3 is kind of the sweet number. Like, one person writing a design doc is going to make a lot of wrong choices. 2 or 3 people is great because they can call each other. They can say, that's a bad idea, here's why, and there's enough perspective. If you get more than 3 people, then it starts to become a circus, right? It's the same reason like why meetings with more than 5 people never
converge.
Anything. Yeah, never converge. So design docs.
Anybody ever travel with a group of people, like travel around Europe or backpack or something? You get more than 6 people, you can't go anywhere. You go to X corner, and it's a big discussion.
But that's true of a business meeting too, right?
So, exactly. It's also true about meetings.
So I mean, with design docs, I think 2 or 3 people is sort of that perfect number. And then after we got the design doc, we went and we brought it to a larger forum, and we gave a presentation about it. We invited comments, and we put it up on a website, and we started getting feedback. And then we just started coding, and amazingly, about a month or 2 later, we had some very basic working code. And suddenly, as soon as we had working code, suddenly all these people started showing up. I mean, we didn't even advertise, but somehow it was like we crossed this magic threshold, and we said, it's okay now, come on.
But we have to remember, 9 years ago, it was CVS in the open source world. It was only CVS in the open source world. That was it. But now you're erasing history here. You've got to tell about us going into a cave.
It never happened.
There was a lot of people showed up a little bit early almost, and we said, all right, we're going to create this private mailing list and have our design discussions there because these people are distracting us. And
we were embarrassed.
But Brian Bellendorf was outraged. I mean, and if you ever know anybody knows Brian Bellendorf, the guy is never outraged. But he was very angry, and he told us to cut it out basically and get our butts back out there.
Stop talking in private, right? There's nothing. If they're bored by what we're saying, they can leave.
Right, and we were pretty indignantly angry about it at the time. Yeah. But 4 years later, we're laughing about it. He was totally right.
He was.
Right?
So what's our other?
Our next case study?
Well, you talk.
Our next case study is the 2 of us. So we've given dozens of talks together over the past, 4 years, 5 years. and we know each other for about 10 or 11. But it's sort of the case study is how we write our talks. I mean, what we've done over the past 5 years is we put the phones away, leave the laptops at the office, take a couple notebooks, and go to a cafe. And then they close the cafe.
Paper notebooks, made of tree.
And they close the cafe, and we find another cafe, and they close that cafe. So if we show up in your cafe, you might want to throw us out. But we sit down there, and, I forgot to plug in the laptop.
Oops. Good thing we're almost done.
Yeah, good thing we're almost done. There
Except
it is.
we lost our video.
Lost our video? Is there a power plug on here?
There it goes. No. Grab it.
No, it's over here. Sorry.
That's it.
So this is a great example of failure. This is why we did this. This is completely intentional. You get the plug over there? Thank you.
There we go.
All right, that's much better. Okay.
Awesome.
Gosh, I feel stupid. So case study is forgetting to plug your laptop in. So we sit down on paper, and we just brainstorm. One of us usually has an idea for what we want to talk about. And we'll brainstorm, we'll sort of riff on that idea, and we act as filters for each other. Oh, we think, that's a good idea, let's go in that direction, let's not. And what we wind up with at the end is a whole bunch of ideas, and then once we get the ideas together, we put it together in an outline and try and make it a little bit more coherent and group-like things together.
Mm-hmm. And then someone else goes and puts it into slides, and then gives it to the other person, and they change the slides, and it sort of bounces back and forth, right? But it's a nice gradual evolution. At no point are we hiding from each other or stopping.
But another thing we learned is that if you're going to give a talk at an event like this, you want to actually not walk in here completely fresh and never having spoken this before. So we can stand at home or in the office and do it in a conference room. But we decided to give a presentation at the local user group in Chicago. And we learned some things about what didn't work. For example, when you're speaking to a room full of 19-year-olds, they don't know what CVS is. Then we also gave it to the engineers in our office in Chicago, and we got some great feedback from them. And then we gave it here, and we learned to plug in the laptop.
Hey, we're iterating quickly.
Yes, exactly. That's the first time I've made that mistake, and hopefully I won't fail in that way again, at least.
All right, so let's just back up really quick. We have our obligatory summary, just in case you forgot what we were saying. So there are no geniuses. We are not geniuses.
There are very few geniuses. Is Jeff Dean here?
Okay.
Okay. I was told by another Google if Jeff was here, we're going to be in deep trouble.
Yeah. So there's no geniuses. It's our natural instinct to try and want to be a genius, but we should fight that and actually try to collaborate as much as we can, early, often. Don't be afraid of collaboration. And pay attention to what your tools are doing to you and the people you work with, because they do affect your collaborative behavior. And finally, make sure you're paying attention to when you collaborate, right? Not too early, not too late. It all is sort of, there's a critical sweet spot for success in your collaboration.
Right. And of course, there's actually a secret to all this that you probably shouldn't share outside of this room. But believe it or not, if you actually do all these things, people will think you're a genius. Ooh. So, because it's not the typical thing that people do. People don't make themselves vulnerable. They don't sort of, they're not open to influence. And
that's it.
But that's it. Thanks.
Yeah. We got 15 minutes.
Yeah, we have some time for questions and answers. So if anyone has any questions, or preferably answers, there's some mics in the center of the room. If you could get up there and...
Uh-oh, two at once.
Protocol.
Two questions. One for the audience, actually. Who would consider themselves a pair programmer?
See, they can't get their hands all the way up.
Yeah.
Come on.
And then the same question to you guys, really. What do you think about pair programming, kind of formally?
I personally think it's ideal if you're working on something really difficult. When I wrote CVS to SVN, which is probably one of the hardest things I've ever worked on in my life, I learned more about CVS and RCS than I wanted to learn ever. Carl Fogel and I did a lot of pair programming. It was really good because it was really grungy, difficult problems. But for sort of day-to-day, I prefer more of the write and code review process.
I think it creates social stress, right? If you're pair programming with somebody, you better know each other really well and be very tolerant of each other's quirks, right? Otherwise, you can start arguing about whoever's driving, right? Don't format the code that way, or don't you know that shortcut, or it can get a little mad.
There's a number of really good engineers at Google who pair program all the time, and they do a great job of it, and they're amazingly productive.
Yeah.
Thanks. Yeah. So advice on dealing with egos, because I agree with you guys, but there's definitely people on the team that, their ego is always in the way.
Advice on dealing with egos.
What is the advice?
How do you deal with people who have a big ego? Is that the question? Wow.
And get them to understand.
Pass. No, I'm kidding. That's a hard question because typically if they're running the project, they'll, again, like attracts like, okay? People who are sort of the friendlier, nicer, consensus-building people are going to attract people that like to work with that. People who are the big, ego, it's about me, let's be aggressive here, I'm the alpha male, let's fight about things.
They attract other alphas.
Exactly. They're going to attract other people that either want to follow them and be like, oh, yes, you're right and wonderful, or the people that just want to fight them because that's what they want to do. So I don't know that I have a particular recipe. We have another talk that you can find on YouTube if you look for poisonous people that talks all about how to protect your projects from poisonous people. So there's a little plug for that.
That's actually...
We gave it here last year, actually.
That's actually probably the best prescription we have is that talk. It's just how to deal with difficult people in general in their project.
Yeah. Next question.
Hello.
Hello.
Let's say if we can deal with some constructive criticism here, if it's okay with you.
Yeah.
It sounds to me like what you're saying is almost like humanistically programming, which is fine, except what it prelates, you have to be in a certain kind of environment. And maybe your company has set up a certain kind of environment at a certain stage in time that this kind of way of dealing with things works. Mm-hmm. But in a different kind of environment, that is the majority of the world, I feel that a lot of the things you're talking about, people are going to get crucified. And I'm not saying that's bad or good, I'm just saying that's the reality of things. It's like when I talked to Kent Beck, 8 years ago about extreme programming, the problem with all the guys in the class was, nobody's going to want to, I'm going to take this back to my company, and nobody's going to want to do this. So my first thing is that you have to be very careful about applying these things because you go back and do these things and you're going to get in a lot of trouble in a certain environment. Secondly, the no ego thing is, great, we'll just send everyone off to a Zen center for a year. People have egos. I'm a psychologist for 30 years. I deal with people, and that's real. That's an ego thing. Thirdly, there's plenty of evidence that there are geniuses in the world. I think that's obvious. And there's plenty of evidence that there's a whole range of people that are good at programming. Some people are good. There's a fair amount of research that talks about the great programmers can write 100 times better. And I'm going
to stop you there. I don't disagree with you on that. Can you hold on a second?
Yeah.
I don't disagree with you. I'd be glad to talk to you a little more offline.
Yeah.
But, the genius is a myth thing is definitely a straw man that we're setting up. There are geniuses, but the point we're trying to make precisely is that they're remarkably few. There are far fewer than most people realize. And I think our talk is much more aimed at people who are able to control their project or their environment. If you're in a corporate environment or something where that you have no control over the actual way the software is developed, you're going to have a very hard time doing that. And you're right, you might get crucified. And our legal staff has asked me to say this is not medical advice, please be careful. But please, we'd love to talk to you more about it afterwards in person.
Yeah, I think we're describing the ideal here, right? Getting from the ideal, actually implementing that and making it happen is a whole separate problem.
Right. I mean, we deal with the open source world for starters. And then coming to Google, it's run inside like a whole bunch of open source projects to some great extent. So it's a similar sort of gestalt.
Right.
Next question?
Hi. I hope this will be interesting to many people. So you mentioned being a small fish. Do you have any advice so if you're in an environment where you're not a small fish, so how to change that, or without leaving the environment, of course, or how to find other ways to improve your skills?
So the question is, if you're a small fish, how do you deal with, how do you become a big fish?
If you're not a small
if you're a big fish, how do you become a small fish, right?
You hire a bigger fish.
Yeah, that's it. I mean, you actually, if you're talking about in a corporate environment, if I were in that situation, I would start looking around for bigger fish, right? Where are the really hard projects? Where are the people who are much more knowledgeable than me? How can I somehow get involved with what they're doing, right? And maybe it's just slow involvement at first, but try to sort of creep your career in that direction, because if you're not being challenged, if you're not a little bit scared all the time, just a little bit, then you're not going to improve. Now, it's not a guaranteed solution. Sometimes you may be trapped. In which case, I guess I might just go look for another job if I were truly bored at my job, right?
Right. And if you're in the open source world, you typically want to attract these kind of people to projects. So if it's built on consensus and other people can still come in and have an influence, that's typically what will attract the bigger fish.
So you're saying if you can change it in your corporate environment, start an open source project, basically.
Again, corporate environments it's really risky. If you are one of the small fish, or like you're just an engineer on a large project, you have no power to change that necessarily. You can do what you do, but you're not going to be able to guide the project from that seat that you're in.
Say, if you're a big fish in a corporation, you probably do have a lot of power to start migrating your career towards other bigger fish, right?
Right.
It's possible.
Next question, please.
Hi. You talked about avoiding a low bus factor and having as many people look at as many pieces of code as possible. And you talked about it in the context of people being egotistical and wanting to own a piece of code and no one else touch it. But I think there's a practical factor there when you have a big project with few people, that the more proficient someone is with a component, the more quickly they can implement features or solve bugs. And if everyone spreads themselves too thin, maybe development would slow down. I don't know. I feel like this is true on my project and my work experience. So like when bugs come in, we want to assign it to the person who knows that component best so they can fix it fastest.
Right.
But we've thought about maybe purposely assigning bugs to people who know it less to help spread knowledge.
Yeah.
Is that a good idea always? Is this concern completely false and just coming out of ego?
I think there's a tension there, like you said, right? The fastest thing to do is to have the people who know the code best work on it, right? But you need to sort of find a balance, right? Where you're balancing short-term versus long-term. In the short term, it's best to have the experts work on the code they know because it'll get done faster, right? In the long term, though, you want to occasionally, like you say, maybe have someone who doesn't know that code as well pair program a bug fix with somebody who does, right? Or give somebody a small task in that foreign area of code, which isn't particularly time critical, but will give that person some experience of the code so that if the expert does get hit by a bus, you'll be covered for the long term. So yeah, it's about risk management, right? But, short and long term.
I mean, and we're certainly not advocating that everyone in your project knows how to do absolutely everything in the code base. There's ways of improving your bus factor without actually making everyone into a generalist, and that is good, solid documentation in the code and comments, design docs, and then just general documentation.
And code review, right?
And code review.
One person, if there's code review going on, then it's really pretty much impossible for one person to know an area of code. Somebody must have reviewed that code that went in there, right? So at least have a cursory knowledge.
Next question, please.
Thank you.
In the front.
Hi.
Yes. You were talking about technological solutions for social problems, and you mentioned that Get and other distributed systems have this problem where the first thing you do is fork. But I wonder if and I don't want to put you on the spot because I think this must be some sort of competitor of yours, but GitHub has taken that model and sort of mushed it together. So it's both you fork, but when you fork, somebody else can see that you forked their code. And we've had cases where I worked lately where we have fixed something and the next day it would get pulled back into the main branch. So I wonder, how you think about that, and maybe even if Google Code was thinking about going somewhere in that direction.
Well, Google Code actually supports Mercurial now. And yes, we are working on the whole sort of server-side clones, much like GitHub. I think that's going to be coming. We're working. It's not deployed yet, but it's definitely on our roadmap to sort of have, having users be able to clone repositories on the site and do pulls from them the same way GitHub does. But what I was saying was it was a balance, right? Yeah, people start out forking, but on the other hand, it's a much lower barrier to participation than with a centralized system. So I think it balances out, right? Or maybe it's even better in the long run for participation.
We have one last question, it looks like.
Yeah. Hi. You did give a very nice talk about...
Into the microphone, please. Sorry.
Yeah. You did give a very nice talk about how you should be in a typical team environment. But usually what happens in your work environment is that when you start implementing what you just talked about, it's not just about becoming a genius, but you become a guinea pig. Your manager wants you to write more code. Your peers look up to you, even though you're a small fish. Just out of college, they expect you, you know, all this API, just bring up a magical solution. And of course, it's like a little bird trying to pull an airplane. And then you're kind of in that limbo where you want to code, but you're afraid of coding. And the more you code, your manager wants you to code more. And then suddenly you start to dream code. Your girlfriend's become angry on you because you forget about her. Your mother complains because you're not calling her. So all these psychological problems come up. So how do you actually think about it?
We have another talk in 5 minutes on how to replace your manager. No, I'm just kidding.
I don't think I've seen that situation. But you're talking about a general pressure to write more code? I mean, I guess I'm quite.
I think it's a pressure from management to behave in one way when it's not necessarily better for the team. That's a general gist of what you're talking about?
It's just a matter of becoming a guinea pig. You are the one who you become a victim of experimentalization.
Right.
So.
Victim of experimentalization. Wow. I don't know.
I don't have a solution for that necessarily. But anyway,
I think we're out of time right now.
I think we're out of time. But
darn, rats.
Thanks everybody for coming.